Hey, hi, welcome to this series on pointers. In this lecture, we're going to introduce the int star operator. The agenda is as follows. We'll be getting introduced to the pointer variable. So we'll be getting introduced to the pointer variables. We'll be seeing how to access data through pointers, and we'll also understand what is aliasing. Uh, so that's the agenda of this lecture. So in on the last lecture, we saw that star of and of x equals star of and of y, where x and y are integers, is same as x equals y, right? It's exactly same. So star of and of x is kind of an alias of x, which means that wherever x is used, one can go ahead and write star. Wherever x is used, one can go ahead and write star of and of x. Both are alias for each other. Star operator is used to access a memory location, right? So star operator is used, you can use a star operator on any address. In the address you can have an integer sitting residing, or you can have a character residing, or you can have a short residing, or any other data type. So you do a star access, it requires an address, and when you do a star access, it either accesses the integer, character, or short depending on what is residing at that address. We saw that the pointer arithmetic is different from the normal address arithmetic. And of x of plus n is not same as x plus n. And of x plus n must evaluate to legitimate address of integer. So in fact, we saw and of x plus n is nothing but, just give me a second, and of x plus n is nothing but and of x plus size of int if x is of type integer. So if x is of type integer, we saw and of x plus n is same as and of x plus size of and of x plus n is same as and of x plus size of integer. Uh, so when just like I said, star can be applied on any address. So in the address, if x resides, and of ix will give the address of and of ix, and of ix will give the address of ix. So star operator in such a case will access an integer. And in case of star of and of cy, where cy is a character, this star operator will access cy for a character. So it will access a character. So if integer is 4 bytes, this operation will result in access of 4 bytes, and if character is 1 byte, this access will star operator will result in an access of 1 byte. So when we do y equals x plus 4, where x and y are integers, we saw that x is used for the address corresponding to x is fetched by the underlying processor, and it's added to 4, and the address corresponding to y is written to. So there are two memory accesses in this case. So I'm going to introduce pointers now. This is the standard type. So let me put it further. So the way we have to imagine now is the star operator. Now when I say int ix, one imagines that ix contains an integer. Similarly, when I say int star ip means that variable type is int star and ip is name of the variable. So the variable ip contains int star, and int star means it's an address of integer. So in that sense, if you take a look at peep into ip, like if you peep into ix memory location, you'll find an integer. If you peep into ip memory location, you will find a number, but that number represents address of an integer, right? So here I'm evaluating star of ip equals and of ix means ip contains the address of ix. So that's illustrated in this diagram. You have ix, cy, these are the variables and these are the addresses. So when I assign star of ip equals and of ix, the ip variable contains the value of 1000. This is numerical value only, but it is interpreted as the address of ix because ix sits at address 1000, right? So that is what ip variable does. Ip contains the address of ix. So let me proceed further. Now what is IP evaluate to? Just like IX evaluates to a value of integer, IP, the mere IP will evaluate to value 1000. And of IP is the address of IP. So address of IP in this case is 1008. IP equals 5000. Though this is syntactically invalid. Remember that although IP contains 1000, as far as the compiler is concerned, this must be an address type and an address of an integer, right? The type of the variable value that is sitting in here must be address of an integer. When you do IP equals 500, the compiler will say, hey, 500 type is not of an integer address, it is an integer. So it won't allow this access. Next we have, so it's invalid. The compiler will say that, we'll talk about this, just postpone it for a minute, but the compiler will not allow this operation. Okay, so now let's get actually introduced to the pointers. So let's say int star of IP equals and of ix. Like I said, int star is the data type. The way you have to read is int star is the data type. So which means that IP is of type int star, which means that IP contains an address of integer. Just like ix equals 8 means ix contains an integer value, int star IP equals and of ix, IP contains an address of an integer. And in this case, like you saw in the previous diagram, IP contains the address of ix, which is 1000, so it contains the value of 1000. Now remember, the star operator can be used to access any address type. So if I do star of IP, can I do star of IP equals 0xAA? Absolutely, because IP contains an address of integer. So I can do star of IP equals 0xAA. So in reality, how will this get evaluated to? IP evaluates to 1000, just like we saw. IP will evaluate to 1000. So star of IP would evaluate to star of 1000. So which means that star of IP will evaluate to star of 1000. So basically you're accessing the address 1000. Since it is on the left hand side, which means you're writing. So when you do star of IP equals 0xAA, IP, this address 1000 is accessed. So which essentially means that access the address 1000 for writing the value, for writing an integer. Access the address 1000 for writing an integer and write a value of AA to it. So in that sense, when I'm writing to star of IP, what I'm doing when I'm accessing star of IP, I am accessing the variable ix. So when I'm accessing star of IP, I am actually accessing the variable ix. So writing to star of IP is same as writing to ix variable. Now, as a result of this, what really happens is that you can see that when I'm writing star of IP equals 0xA, at the end of it, you can see that the value has changed to A. Right? When you do star of IP equals 0xA, the end effect is writing to the variable ix, but we're writing to variable ix. So star of IP does evaluate to ix. Let's take it further. Let's see ival equals star of IP. So in this case now, you're reading from the variable IP. You're reading from the star of IP. So star of IP is on the left hand side, right hand side, sorry. IP evaluates to 1000. Star of IP would evaluate to accessing star of 1000. Now it's on the right hand side, which means you have to access for reading purpose. So basically, as a result of this, address 1000 will be accessed for reading purpose by the underlying processor, and ival equals 0xAA. So now ival will become, sorry, so I hope, so ival will become 0xAA. Right, I'm sorry, it should have updated. So ival here should have become 0xAA. So now in this case, you can see that when I am reading from star of IP, it's as though I am reading from the variable ix. And earlier we saw when I am writing to star of IP, it's as though it's writing to the variable ix. So for all practical purposes, star of IP is same as ix. See the value changed to A, and for all practical purposes, IP is the same variable as ix. Hence, star of IP is called an alias of IX. So by merely doing this operation star of IP equals and of IX, star of IP becomes an alias for the variable IX. So this is very important. Star of IP is the same as the variable IX. The star of IP is an alias for IX. So this is very, very important for the this will take it as an assignment. I will not get into this. So let's introduce the index notation. You saw the star notation to access address. Now let's take a look at the index notation. Let's go to the famous path again. We saw this. We saw this. Now let's take it. Let's take the operation star. Let's take IP of 3 equals 0x Now, what does this mean, IP of 3? As far as the compiler is concerned, the IP of 3 equals 0x is exactly same as IP is same as and of IX. We saw that. So IP of 3 is actually the way the compiler interprets is IP of 3 is same as star of IP plus 3. That's the interpretation by the compiler, not by me, but the compiler. Star of IP plus 3. So which is same as, now remember this is an address arithmetic, not a normal arithmetic, address arithmetic, and IP contains the address of an integer. Remember, IP contains the address of an integer. Like we learned in the previous class, when you do pointer arithmetic, it boils down to the following integer arithmetic. So IP plus 3 would boil down to the value of star of IP plus 3 into size of integer. Why? Because IP contains an integer. So which location is it going to access? Let's see further. So if you take IP is 1000 plus 12, assume the size of integer is 4, so that will be nothing but 1000 and C. So this will go and update 1000 and C. So if you take a look at it, this IP of 3, when I write it to IP of 3, right, it becomes the third location from starting from address 1000. Right, this IP of 3 would become third location. If you take a look at this IP of 3 evaluates to this variable, which is ival. We just now saw IP of 3 is nothing but IP plus 3 into size of integer, so that is nothing but address 1000 and C. So in that sense, IP of 3 is same as ival, and IP of 3 evaluates to the address 1000 and C. IP of 3 evaluates to the access to the address 1000 and C. Next, IX equals IP of 3 will be exactly opposite of it. Not opposite. Here you will be using IP of 3. You will be reading the location 1000 and C and writing it to IX. That's what this is showing. IP is same as and of IX. IP of 3 same as star of IP plus 3, which is IP plus 3 into size of integer, which is like reading location 1000 and C. Right. So 1000 and C now. You saw that IX becomes A. Now, if you take a look at it, now the IP of 3 looks like you're accessing an array. Actually, it is an array. One can imagine that there is an array starting here with 0th element at address 1000, the first element at address 1004, the second element is at 1008, and third element is 1003. So, which means that IP of 0 will evaluate to IX. IP of 0 will evaluate to IX. IP of 1 will evaluate to the integer beginning at address C1. Remember, IP of 1 will evaluate to 1008. IP of 1 is access to the integer variable that is beginning at address 1008. It's as though there is an integer variable that is residing at 1008, and IP of 1 will access that integer variable. IP of 2 will access IP itself. IP of 2 evaluate to access to address 1000 and IP of 1 will be again is 1004, access to the variable. Sorry, I'll just clear this and try it out again. So IP of 1 would evaluate to access to location 1004 for an integer value. IP of 2 would be 1008, which means when you're accessing 1008, But accessing IP itself. You can see that if you're accessing, if you say IP of 2 equals, for practical purposes 0x2000 or something like that, and actually this variable itself, this address location will itself get modified, and IP of 3 will be IVAL. So one can imagine that there is an array sitting over here. One can imagine that as though there is an array of IP of 0. At the first location, this location is IP of 0. Now this location is IP of 1. This location is IP of 2. And this location is IP of 3. Just because of one pointer assignment. Just because of one pointer assignment, you can treat the whole memory location as an array. So we saw IP of 0 is nothing but star of IP of 0. IP of 0 is nothing but star of IP plus 0 into size of integer, which is 0, which is same as star IP. So IP of 0 is nothing but star of IP, which is nothing but IX. IP of 1 is the integer beginning at address 1004. IP of 2 is same as IP, right? IP of 2 evaluates to same as IP because it evaluates to access 1008. So that's what we saw. This is the how we saw that an array is placed at that location. So what we saw is um, so int val IP one can do just to recollect IP equals and of ival. This assignment is very valid. And of ival evaluates to an address. So and of ival evaluates to an address. So would IP. So IP is an evaluates to address of an integer. So what this is trying to summarize is the star of IP is same as IP of 0. Okay, star of IP plus 1 is same as IP of 1. Notionally, both of them are exactly same. Okay. So how do we access pointer through index? Let's get back. So when you say IP of 0 equals 0xbb, let's take a look at this. When you say IP of 0 equals 0xbb, now IP contains the address 1000. So IP of 0 would be equivalent to accessing an integer variable at address 1000, which is nothing but IX. Right? So IX equals 0BB means variable IX would change. Right? We saw that IX is changing to BB. IP of 1 equals minus 1 is the variable or is an integer. It evaluates to access to an integer variable at address 1004. So IP of 1 equals minus 1 would make the integer variables, which is 1004, 1005, 1006 and 1007, 4 locations as minus 1. So all these locations would be written as FF. That's what is happening. So all these locations. Now imagine this, right? The beauty of this is by accessing IP of 1, I am modifying the variable CY as well as I am modifying the variable SSI. So that is why pointer access is very dangerous, because you can modify other variables also. Because pointer is through pointer access you are actually writing to raw memory. You are writing to memory 1004, 1005, 1006 and 1007, and in that memory location any variable can reside. So pointer access can lead to corruption, and it will lead to corruption if your programming is bad. Now IP of 3 equals IP of 2 plus 8. Now IP of 2 is what? Now IP of 2 would be the integer sitting at address 1008 plus 8. So 1008, integer sitting at 1008 is value so much, 1000. To that you're adding 8, so that becomes 1008, and you're writing that to IP of 3, and IP of 3 is nothing but IVAL. Okay, so as a result of this, IVAL becomes 1008. So in general, IP of n is same as the integer variable that is sitting at address IP plus n. So IP of n is same as access to the integer variable that is sitting at address IP plus n. Now this you have to remember very well. Though though may not be any integer sitting, it's as though there is an integer sitting at that address, and IP of n evaluates to that address. So another thing is pointer can not only access indirectly variable IVAR, but many other variables. We saw that a pointer, through pointers you can access any memory location, right? So you can access any memory location. So one has to be very careful with pointers. So to summarize, if you have int star IP becomes a variable. The way you have to read is IP is of type int star. The type is very important. You have to understand what is type of a variable. IP is of type int star. IP contains an address of an integer. And int star IP equals A. In this case, star of IP contains the address of variable A. And star of IP is same as IP of 0. And in this case, star of IP is an alias for A. And IP plus 1 would be an alias for integer variable setting an address A plus 1. Remember, again, this is a pointer arithmetic. And we also saw the indexing operation. So we saw this is a very important session. Would stop here for this, but you need to summarize still here and make your fundamentals clear regarding pointers, addresses, and the index operation. Thank you.